So I want to talk about some more external features of the database. I want to talk about views in particular. And what a view is it's a picture of data. It's a picture of data from your database at that instance. And I can combine tables to make a view. So the example down at the bottom is customer and sale, and I need that information all the time together. So what I can do is create a view that combines that data together, and it'll run a little faster for me than if I had to go and do all the joins and all that stuff on my own. And it doesn't duplicate the data, so I'm not creating size. I'm not increasing the size of my database, so I'm not going to have the data from the customer and sales tables in addition to data for the views. It's looking at the data from those two tables. It's a good way to implement some data security because it restricts certain data to users. So I have users that need to see some information from the customer and sales table, but they don't need to see everything. So you can see in the sales table there's transaction ID, customer ID, store ID, date, and amount. But in the view, all that exists is transaction ID and customer ID. It's at the front. It's the primary key there. But I also have date and amount. So I don't have the store ID. Maybe they don't need to see that. I can also split my tables. I can split my tables horizontally, or I can split my tables vertically. And it's a feature within the DBMS is that I tell it to partition my my tables that way. So if I want to split horizontally, if you think about the way the table looks and I run a line across it horizontally, I'm splitting my I'm keeping all of the all of the columns and only some of the rows. Okay, so excuse me. Here I have Northeast customers and I have Western customers. So if this was my customer table and I partitioned it horizontally, what I can do is I can make it so each region has their own file for that table, and it's going to make their searches and their accesses much faster. Now I can split the data vertically as well. So in this case, you picture a table and the line is going vertically. So some people are going to see some columns from the database and all of the rows, and others will see other columns from that same table, but all of the rows. Okay, so here's an example where I have my customer table, and my marketing department really only needs to see the customer ID and the name and all of that kind of information. But my billing department, they really need to just see the amount that's being billed, things like that. So this is one table, but it's been partitioned so that it's stored separately like this. And it's going to allow some performance gains for me. If I need to create a new primary key, okay, do I need to change my logical design? So this is the example we used in class last week where we had a 4-column primary key, and in this case I can get rid of that 4-column primary key and just have a single column for the primary key. Maybe I use transaction ID for that. So it's going to allow my joins to be faster and my queries to be much faster because it's a single column is much faster in a join than multiple columns. Now, if I want to add attributes to my database, let's say that so the example down here is annual purchase, or there's different things that are calculated that I can store. Maybe you want to know you want to know what somebody's raise will be if they've had a 10% increase, or you want to see some sales projections based on some increases over the years. Something is calculated, not just a number that's entered into the database. That information is derived from other columns or other information. You can do this two ways. You can store that information in the database, or you can have the application, the front end that you're using, create that. And you just have to decide as to where's the best place to do it. Maybe this annual purchase, maybe I need this all the time. Maybe it makes more sense for the database to calculate it and to keep track of it, because I have lots of people querying the database to find out what their annual purchases are. In that case, it may make more sense for me to have it done on the database. But let's say that it's only a field or a value that gets calculated at the end of the year by a couple of people in the accounts receivable department or something like that. Then in that case, it may not make sense to have the database doing all this calculations throughout the year to keep track of that amount. It may make more sense in that case to have the actual application that accesses the database doing that calculation only when it needs it. So you just have to decide as to when is the best time to do that. We talked about combining tables. This is denormalizing. So last week we normalized our database by separating out based on first normal form, second normal form, so forth and so on. But there are going to come instances when you need to denormalize it, because maybe I've got a query that I have and there's, I don't know, 14 or 15 joins in this query that I'm accessing from all of these different tables. In that case, it may make sense for me to denormalize it and decrease the number of joins that I have so that I can make my retrieval for that query run much faster. So the disadvantages are that my data is no longer logically or physically independent, because if you look at the example down at the bottom on salesperson in office, this was an example we did the other day. I've gotten rid of that foreign key and I now have my office number and location and phone number assigned to the person. But I just had a blank there for a second. You don't want to do this for one-to-manys or many-to-manys. You really only want to do this for one-to-ones if you have to do it at all. Now, if you're looking at a data warehouse, that's a completely different thing. And in that case, you might have one-to-manys or many-to-manys in a single table. But for this class, all we're really talking about is a regular transactional style database, not a data warehouse. So why is office number no longer a foreign key? If you notice in the salesperson table, you can see office number, but it's no longer a foreign key. If you look on the salesperson table at the bottom, you can see it doesn't have the dotted underline. Well, it's no longer a foreign key because the office table doesn't exist. There's no primary key on another table that it needs to point to. This is the kind of, it's kind of a one-to-many, but if it was the repeating group, so if it was just phone number, if it was, and you had multiple different phone numbers all in one field, that's kind of the repeating group. So you don't want to do that if you don't have to, but you can make them separate fields, so home phone and work phone, and add those into the table. Here is an example of a normalized table or set of tables, book and publisher, and here they are combined to denormalize them. And again, it's just another example of when you could denormalize in order to make your queries go faster, because you don't have as many joins. So that's really the reason you would do this. If you have a database and it's a querying style database and you have lots of joins in a query, you want to try and denormalize it to eliminate some of those joints, and that's going to make your performance faster. I think I'm going to stop here as well, and then we'll go on to part 4.